Electron transfer reactions take place when one atom is missing an electron or two, and another one has electrons to give away from its coat. The first thing that you'll need to do in order to recognize electron transfer reactions is determine when elements or ions have coats or don't have coats. If a metal is in its ion state, that means it's missing its coat. It's lost its electrons on the outside and therefore has a charge. If something is neutral, it has its coat, and that's what makes it neutral. So let's look at our two here. Silver has a plus charge. That means it's missing one electron from its outer shell. That means that it's missing its coat. No coat. Because it's lost that electron. It now has one more proton than it has electron, meaning it's missing its outer coat. Whereas in comparison, copper has no charge. That means it's neutral. If it's neutral, that means it has the same amount of protons as it does electrons. Copper has 29 protons, and in its neutral state has 29 electrons. That means that it is not missing its outer ring of electrons. It has all of its electrons that it needs. So this one has a coat, or wearing a coat. So if it has a charge, that means it has no coat. So if it has a positive charge, that means it's lost its outer electrons, it has no coat. If an element is neutral, that means it is wearing its coat. It's got all the electrons that it can have. Electron transfer reactions between metals must meet the following requirements. There must be a metal that has electrons to give away. You can't steal someone's coat if they don't have a coat. There must be a metal that wants electrons. If you already have a coat on, why are you going to be out there stealing coats? So you need to have somewhere for the electrons to go. Lastly, the metal ion has to be strong enough to steal electrons from the metal that has the coat. If a really strong element has a coat, there's no way that a weaker one is going to be able to rip it off of it. When determining the strength of an ion, you can look at the activity series. So here's our periodic table. On the side is our activity series. At the top, we have the weakest. And at the bottom, we have our strongest. An element that desires a coat must steal from an element that is weaker than it, meaning you can only steal up. So gold's the strongest. It can steal from anything on the list. Whereas lithium is the weakest, it cannot steal from anybody. And then we have, for example, zinc. Zinc can steal from aluminum, magnesium, sodium, calcium, potassium, lithium, but it cannot steal from anything below it. It is not strong enough. So when you're determining whether or not an electron transfer reaction can happen, you must keep in mind the strength of the elements that are in the reaction. Just because there is an element with a coat and an element without a coat doesn't mean that a reaction automatically happens. If they're not the proper strength to each other, then the reaction won't happen. Describe why there can be no electron transfers in the following situation. So it's telling us this cannot happen. Magnesium is mixed with zinc. So we look at our requirements. There must be a metal with an electron to give. Magnesium has an electron to give. It's neutral. Zinc also has an electron to give. It's neutral. So our problem then is with number 2. There must be a metal that desires electrons. No reaction will happen here because these are both solid metals and neither of them desire an electron. As you can imagine, if I just put two metals together, they wouldn't react. So there's no reaction here because there's nothing, no one desires an electron. Number 2, we have silver plus, meaning it wants a coat. It wants electrons. And aluminum 3 plus, it also wants electrons. that means that there is no metal with electrons to give away. If two people don't have a coat, there's nothing to steal. So no reaction here because there's no coat to steal. No coat to steal. Okay, last one. We have aluminum, which wants electrons. We have gold, which has electrons, has a coat. So that fulfills our first two requirements. There must be a metal with an electron to give away. Gold has the electrons to give away. It's neutral. And there must be a metal that desires electrons. Aluminum has a 3+. It wants electrons because it is an ion. It's lost its coat. So check, check. Now we need to check on the third one. The one without a coat must be strong enough to steal. So if we look at our periodic table, we have aluminum and gold. Remember, you can only steal up. So aluminum is trying to steal. But it can only steal from the elements that are above it. It's too weak to steal from gold, so this reaction will not happen. Now we're ready to handle electron transfer reactions that do occur. When the requirements in question 2 are met, then a reaction will take place. The metal that does not have a coat will take the electrons and become neutral, and the metal that lost its electrons will become charged. So we need to write out the products of our reactions. So copper 2+ is mixed with zinc. That will make a neutral copper and a charged zinc. Zinc only has 2 electrons to give away, and copper is going to take both of them. To figure out the charge of the ion after the reaction takes place, consult your solubility chart for these transition metal charges. For B, nickel 2+ is mixed with iron, so nickel is going to steal electrons from iron, and that'll produce nickel metal and iron ion 2+. So that's nickel metal and iron ion. I'll let you do the last one on your own. Take note, though, of what copper is on the solubility chart. Look at the charge it becomes before you just write down any old charge.